the dry bulb and the wet bulb temperatures directly refer to methods of measuring the humidity of a given moist air. So this method is called the two-thermometer psychrometer. Psychrometer just means measuring the humidity content. In this method, we take a given moist air and this moist air will go around two thermometers. The first one is just a normal thermometer that we call dry bulb thermometer, and the second one is covered by a felt or a cloth that is constantly humidified with liquid water reservoir that will keep this felt always wet. When the moist air will go next to the felt, there's a good interface area between the liquid water and the moist air, so the liquid water will evaporate until the air is completely saturated. So the air that will go inside the felt, so where we have the wet bulb, will be a saturated moist air. And the evaporation process will cool down the air because of the latent heat of vaporization of water. So part of the sensible heat from the moist air will be transferred into latent heat due to evaporation. So this one is called the wet bulb thermometer, and it measures a temperature that is below the normal temperature of the moist air, and the dry bulb temperature measures what is called the dry bulb temperature, but it exactly corresponds to the normal temperature of the moist air. So how to understand what is happening around the wet bulb thermometer? So we can do a very simple model. We can consider that there's just a mixing process with two inlets. One inlet is a given mass flow rate of moist air with a given specific enthalpy called H moist air, and the mass flow rate is written with the mass flow rate of dry air, because the reference of mass is always the mass of dry air. This flow rate of moist air is mixed with a given mass flow rate of evaporation of liquid water at a given specific enthalpy, H indexed W for water. And inside this system, things are happening, especially this water is evaporating, and what we get at the outlet is a saturated moist air with the same mass flow rate of dry air, because nothing has changed for the dry air, but with a new specific enthalpy written H of saturated moist air. So because we have no exchange of energy with the outside, we can write the conservation of the enthalpy flow rate, and this will be written as the product of the specific enthalpy of saturated moist air times the mass flow rate of dry air is equal to the flow rate of enthalpy that comes from the moist air plus the flow rate of enthalpy that comes from the liquid water. This can be written as the specific enthalpy of the saturated moist air is equal to the specific enthalpy of the moist air plus the specific enthalpy of water multiplied by the ratio of mass flow rate of water that is evaporated divided by the mass flow rate of dry air that is coming. But here we can do two approximations. Third thing is the specific enthalpy of water is usually very small in front of the specific enthalpy of moist air, because this one also contains some enthalpy due to latent heat of vaporization because of the moisture content that we have inside. And because the latent heat of vaporization is huge, this specific enthalpy is usually much bigger than this one. The other thing is that the mass flow rate of evaporation is always very small compared to the mass flow rate of dry air. This is due to the fact that, as we have presented before, the proportion of water in a moisture or in a saturated moist air is always very small, because the saturation pressure of water in normal temperature conditions is always very low compared to the atmospheric pressure. So for this reason, we can reasonably neglect this second term and say that the specific enthalpy of the saturated moist air is equal to the specific enthalpy of the moist air. So then, coming back to our measurements, what did we do exactly? Between this dry bulb temperature and this wet bulb temperature, the air has been saturated at constant specific enthalpy, so until being a saturated moist air. And with the measurement of this temperature, it is possible to know other kinds of parameters like the moisture content or the relative humidity, in order to specify what moisture content we have inside the moist air that we are measuring.